We've all heard the advice, if you want to teach something complicated, just wrap it in a good story. But what if that's not quite right? In today's Explainer, we're going to dig into some really cool research that puts that whole idea to the test. So let's get right to it. Is storytelling really the learning superpower we all think it is? I mean, does wrapping facts in a story actually help us understand the world better, or is the truth a little more complicated? Okay, let's start with this idea itself. It's become almost like a golden rule in education and marketing, you name it. The thinking goes that our brains are just, hardwired for stories. If you embed information inside a narrative, give it characters, a plot, some drama, it'll be more memorable, easier to process. And look, on the surface, that feels totally right. But a group of researchers wanted to know if this popular wisdom could actually stand up to a real scientific test. And the subject they chose to test this on was a doozy: basic concepts in biology. These are ideas that students find notoriously hard to get right, even university science majors who were just taught this stuff. And a big part of why biology is so tricky is something called the teleological mindset. It's basically our brain's default setting. We have this very human need to see a purpose or a goal in everything, even when we're looking at a totally random natural process. This is the perfect example. It's so easy to think that bacteria evolve on purpose to fight antibiotics, right? Like they have a goal. But that's not what's happening. The reality is way more random. Some bacteria, just by pure chance, already have a resistance gene. So when the antibiotic shows up, they're the only ones left to survive and make more copies of themselves. It's a critical difference. There's no goal, just chance and survival. So the big question was, could a good story help students get over that mental hurdle? To find out, researchers at a Swiss university set up this awesome experiment: a head-to-head battle between learning with a story versus learning with a traditional, straight-up text. For this experiment, they recruited 74 first-year undergrads who were studying medicine or health sciences. These students were just starting out, which made them the perfect group to test these different teaching styles on. So here's how they did it. They split the students into two groups. One group, the narrative group, got a text that wrapped all the science into a historical story about how these ideas were discovered. It was a bit longer and definitely written to be more engaging. The other group, the expository group, got the classic textbook treatment. Just the facts, no frills, direct and to the point. And you can really see the difference here. The story version sets a scene, right? It's got a person, Robert Brown, and his mistaken idea about a life force. The textbook version, though, it just cuts right to the chase. This is called Brownian motion. One's a story, the other is a definition. So, who do you think learned more? The students with the cool story or the students with the boring but direct facts? Well, the result was not what you'd expect. Just look at these scores from the tests they took afterward. On the concept of randomness, the scores were almost identical: 4.03 versus 4.09, and for enzyme energetics, same story: 2.53 versus 2.86. In the world of statistics, a difference that's small is basically meaningless. It was a tie, a dead heat. So the big headline here is that, on average, the story didn't work any better than the dry old textbook. The supposed learning superpower, well, it kind of fizzled. But hold on, because this is where things get really interesting. The researchers had a hunch that there was something else going on under the surface. They started to think that maybe not all students were coming into this with the same foundation. And when they dug into the data, they found it. The secret ingredient that changed everything was prior knowledge. They started asking, what if how well a story works depends entirely on what you already know before you even start reading it? And boom, when they separated the students based on whether they had a background in science, a really clear pattern popped out. For that really tough concept of enzyme energetics, STEM majors who read the story scored a 2.95. But the non-STEM majors who read the exact same story, they only scored a 1.92. It seemed like the story only really helped the students who already had some kind of scientific framework to hang it on. So here's the crucial insight. Stories aren't necessarily the best tool for building knowledge from the ground up. Instead, they seem to work wonders when you already have some existing knowledge. The story helps you connect the new information to what you already know. But for a total beginner, all those extra narrative details might just be noise that gets in the way of the main point. Now check out this chart, because it adds another fascinating twist.
It basically maps out test scores against how much productive mental effort the students felt they were putting in. For the textbook group, that light blue line, it's simple. The more effort they put in, the better they scored. Makes sense. But look at the story group, the dark blue line. It's flat. So what on earth is going on there?
Well, it suggests the story was doing a different but still really important job. For the students who were struggling, the story kept them hooked. It kept them thinking hard and trying to make sense of the material. So even if their test scores didn't shoot up right away, the story stopped them from just giving up. It kept their wheels turning, and that is a huge part of learning. And all of this leads us to a much smarter, more nuanced understanding of what stories really do for us when we're trying to learn. It's not always about getting a better grade on the next test. And here's the proof of those hidden benefits. The researchers also measured two other things: how much the students enjoyed the text and that productive mental effort we were just talking about. And on these two measures, the story group blew the textbook group out of the water. It wasn't even close. Students found the story way more enjoyable, and it made them think harder about the topic. Okay, so let's wrap this all up. What did we learn? First, stories are not some magic wand you can wave to teach anything to anyone from scratch. Second, how well they work is super dependent on what the learner already knows. Third, where stories absolutely crush it is in making learning more fun and enjoyable. And finally, they're fantastic for boosting that productive mental effort, keeping us in the game when things get tough.
So this leaves us with a much better question to ask. It's not, are stories good for learning? It's, when is a story the right tool for the job? Figuring out when you need a story to help you connect the dots and when you just need the straight facts, well, that might be your own personal learning superpower.